Welcome back, everyone. I am so thrilled you're here. Today, we're zeroing in on a truly massive global industry, paper manufacturing. It's kind of funny. We interact with paper literally every single day, from those pristine, bright white sheets in our printers to the cardboard boxes piling up on our doorsteps. But contrasting that crisp final product is a gritty, super intense industrial reality that's required to actually make it. Behind your everyday paper is a process of staggering scale. And with that scale comes a series of hidden, localized impacts that we rarely think about, but they have massive implications for businesses, for communities, and for investors alike. So I want to kick things off by asking you to think about this question. What is the invisible cost of the paper we use every day? We always hear about greenhouse gases and global warming, right? But today, we're stripping all of that away. We're looking at what's happening right at the fence line of the factory. We are talking about localized air pollutants. These are the specific emissions created during the highly intensive paper-making process that directly impact the immediate air quality of the surrounding environment. Okay, let's dive right into this. We've got a structured journey ahead, guided by the SASB standards. First up, sources of air emissions. Then, the big five pollutants. Next, navigating regulatory uncertainty. And finally, the business case for abatement. Let's jump right into part one, sources of air emissions, and trace exactly where these originate in the mill. Now, it's really easy to picture a factory just, producing a generic cloud of smoke. But industrial emissions aren't magic. They don't just magically appear out of thin air. They're intrinsically tied to specific, highly engineered thermal and chemical pressure points within the mill. Essentially, every single time you heat something up, break down a wood fiber, or try to recover a chemical, you're creating a localized exhaust stream. According to the SASB standards, we can actually map these emission sources to 4 core operational areas. Think of this as basically building a mental schematic of a paper mill in your head. Step 1 is wood chip pulping. This is where the raw timber is initially broken down. Step 2, the pulp and paper pressure chambers, which are operating under immense heat and stress. Step 3, pulping chemical recovery. This is a pretty fascinating closed-loop system where mills try to reuse their chemical inputs. And finally, step 4, process engines and cogeneration fuel boilers. These provide the massive amounts of energy required to run the whole shebang. So each of these steps is a distinct point of origin for localized air pollutants.
Now, because manufacturers know exactly where these emissions are coming from, they know exactly where to intercept them. This is absolutely crucial. Notice how highly advanced abatement technologies, things like industrial scrubbers, they're placed directly into that pulping chemical recovery loop and right into the exhaust streams of those cogeneration fuel boilers. The whole goal here is to capture the pollutants before they ever get a chance to reach the atmosphere. It's proactive interception, right at the exact point of the chemical reaction.
Which brings us right into section 2, the big 5 pollutants, where we'll identify the critical culprits. Now, what's really interesting here is the official SASB metric. It's code RR-PP-120A.1, and it requires pulp processing facilities to specifically manage, measure, and report on 5 distinct categories of pollutants, all measured in metric tons. We've got nitrogen oxides, sulfur dioxide, volatile organic compounds, particulate matter, and hazardous air pollutants. So let's break these down one by one, because each one tells a slightly different story about the manufacturing process. First up on the roster, we have nitrogen oxides, or NOx, and sulfur dioxide, SO2. These are the heavy hitters of combustion. When you're burning fuel in those cogeneration boilers and process engines we just talked about, these are the primary localized emissions you're going to generate. And a quick but really crucial technical distinction from the SASB framework here, when they track NOx, this includes nitric oxide and nitrogen dioxide, but it specifically excludes nitrous oxide. That's because nitrous oxide is tracked entirely separately as a greenhouse gas. So just a good detail to keep in mind. Next up, we have VOCs, or volatile organic compounds. Now, the standard strictly defines these as any carbon compounds that participates in atmospheric photochemical reactions. But honestly, just as important is what it excludes. It does not include methane, carbon monoxide, or carbon dioxide. Basically, VOCs are a unique class of non-methane organics, and they're the ones that can cause localized smog and degrade air quality right around the manufacturing facility. Then we get to HAPs, hazardous air pollutants. The definition here is pretty sobering, but it's absolutely vital to understand. These are pollutants that are known or strongly suspected to cause cancer, reproductive effects, birth defects, or severe adverse environmental effects. Because of the sheer severity of those health risks, ensuring that HAPs are successfully captured within the pulping chemical recovery loop rather than just being released into the community is absolutely literally critical. Finally, rounding out our big five, we have total filterable particulate matter, or PM. Now, unlike the invisible gases we were just discussing, this is physical, solid matter. We're talking soot, ash, the dust generated by pulping and burning. This really solidifies the full scope of the challenge here. Paper mills aren't just managing invisible gases. They are deploying actual physical filters and scrubbers to physically pull solid particulate mass right out of their exhaust streams. Moving right along to Section 3, navigating regulatory uncertainty and the massive risk of inaction. So the crucial point here is that we're shifting our focus from the industrial chemistry on the factory floor straight to the financial realities inside the boardroom. The big compliance challenge for paper manufacturers is that evolving air quality regulations create this constant moving state of uncertainty. Regulators, well, they love moving the goalposts, right? A limit that is perfectly acceptable today might be completely illegal 5 years from now. And responding to that, it isn't cheap. Emissions abatement expenditures can be highly significant. Just tracking these pollutants to prove compliance requires really expensive technology, like continuous emissions monitoring systems, often called CEMS, or these insanely complex engineering mass balance calculations. It is a massive operational hurdle for these companies. Which leads us to our final section, Section 4, the business case for abatement, or how you turn compliance into an actual advantage. So, you might be wondering, why on earth should a pulp and paper company proactively invest millions and millions in clean air technology? Well, it's not just about checking a regulatory box. It is fundamentally about achieving operational excellence. And this brilliantly illustrates the balance we're striking here. On one hand, evolving air quality regulations risk massive fines, high uncertainty, or in worst-case scenarios, operational shutdowns. But on the other hand, you have the deployment of cost-effective abatement technologies. By proactively intercepting NOx, SO2, and particulates, a company doesn't just appease the regulators, they actually create a lower overall operating cost structure for themselves in the long term. It essentially makes them immune to the shock of sudden regulatory changes. It's a win-win. Let's look at the core thesis straight from the SASB standard document itself. Quote, entities that can cost-effectively reduce air emissions may improve operational efficiency, benefit from a lower cost structure, and mitigate regulatory risk. End quote. I mean, it is a dual mandate. Managing the big five localized pollutants isn't just a corporate environmental responsibility, it's a direct, tangible lever for financial stability and efficiency.
At the end of the day, it all comes down to operational efficiency. The big thing you should take away from this explainer is that cleaner, smarter industrial processes equal a fundamentally better business. For sure. When a paper mill can master its chemical recovery loops and perfectly scrub its boiler exhaust, it proves a level of engineering discipline that almost always translates into better margins and a much stronger long-term viability.
I want to leave you all with this final, provocative thought. We know the rules surrounding localized pollutants like HAPs and VOCs. They're only going to get stricter globally. So as these regulations tighten, will early investment in clean air abatement transition from being a mere compliance cost to becoming the ultimate competitive advantage in sustainable, heavy industry manufacturing? It's a super fascinating space to watch. Thank you so much for joining me to explore the hidden chemistry and the business strategy behind the paper we use every single day. Stay curious, keep learning, and I'll catch you in the next one.